Welcome back, viewers. Today I want us to look at a question on calculus and how we can use calculus to get or to calculate the speed and velocity of objects in projectile motion. Now in question 15, a particle moves along a straight line so that its displacement s meters from a given point is equals to t cubed minus 5t squared plus 3t plus 4, where t is time in seconds. Find A, the displacement of the particle at t is equals to 5, B, the velocity of the particle when t is equals to 5, C, the value of t when the particle is momentarily at rest, and D, the acceleration of the particle when t is equal to 2 seconds. Now we take the given displacement function s is equals to t cubed minus 5t squared plus 3t plus 4. So in part A, to find the displacement of the particle when t is equals to 5, we come and substitute to get the distance covered. We come and substitute for the value of t. We put 5. When t is equals to 5, the question is s will be equivalent to what? So s will be equivalent to 5 cubed minus 5 multiplied by 5 squared plus 3 multiplied by 5 plus 4. When you simplify this, you get 125 minus 125 plus, this is 15 plus 4, which is 19. So 125 minus 125 is 0 plus 19. So the answer gives you, it becomes 19 meters. That is the answer in part A. In part B, you are told to find the velocity of the particle when t is equals to 5. The velocity function is given by ds by dt. We differentiate the displacement function with respect to time. So our velocity function, when we differentiate this, we're going to get the velocity function being given by 3t squared minus 10t plus 3. And we want to get the velocity when t is equals to 5. Again, we come and substitute here. 3 multiplied by 5 squared minus 10 multiplied by 5 plus 3. So we are going to get this as 3 times 25, that is 75, minus 50, that gives you 25 plus 3, this gives you 28 meters per second. So that is our velocity. In part C, we are told to find the value of t when the particle is momentarily at rest. The value of t when the particle is momentarily at rest. In part C, when the particle is at rest, it means the velocity will be equal to 0. And we know that our velocity function is given by 3t squared minus 10t plus 3. So this function should be equal to 0. So this is a quadratic equation, and we can go ahead and solve it. Our product will be given by 3 multiplied by 3. Our product will be given by 9. Our sum will be given by negative 10. And these two numbers, what are our factors? Our factors are given by negative 9 and negative 1. So when you multiply negative 9 by negative 1, you get positive 9. When you add negative 9 to negative 1, you get negative 10. So you rewrite the middle term using those two factors. You will get 3t squared minus 9t minus t plus 3 is equals to 0. So when you factor out here, 3t will be common, multiplied by t minus 3. And here when you factor out, you're going to get negative 1 multiplied by t minus 3 to be equal to 0. Now, at that particular point, we have two expressions. We are now going to have 3t minus 1 is equals to 0, and t minus 3 is equals to 0. So here it implies that t is equals to a third, and here t minus 3 is equals to 0, t is equals to 3. Therefore, the particle will be momentarily at rest when t is equals to a third second and when t is equals to 3 seconds. So that is it. Finally, on the last part, we're told to find the acceleration of the particle at t is equals to 2 seconds. Now that we know our velocity function, is given by 3t squared minus 10t plus 3. Our acceleration function is given by dv by dt. That is differentiating velocity with respect to time. So dv by dt gives us the acceleration function. So when we differentiate this with respect to t, we are going to get our acceleration function as 6t minus 10. 6t minus 10. And when t is equals to 2, come and substitute the value of t right to here. So 6 times 2, this will give you 12 minus 10, which gives you 2 meters per second squared. 2 meters per second squared. So that is your answer. Thank you for watching and listening.